Hi everyone, welcome back to my YouTube channel TechDataEngineer. So in this video, I'll explain data Skew in Apache Spark in very simple but practical way. So exactly how it will happen in a real world data engineering system. Okay. So so this is a problem that is extremely common in production pipelines and very frequently asked in data engineering interview also. Okay. So I'll explain what data Skew is, why one task run forever and how it leads to performance issue and how out of memory error. Okay, and most important like how to fix it properly. Okay, so I have divided this video into different part. First I'll explain few definitions also from basic level, then I'll explain these things, data skewness issue, and what is the solutions for that. Okay, so let's start with the video. Okay, so basically, what is data skew? Okay, so first we will see what is data skew. Okay, so what is data skew? So data skew means data is not evenly distributed. Okay, so in layman term, we will understand like some types of data have more you can say numbers, and some types so some types of data have more numbers compared to other data. Okay, so it means that data is not evenly distributed. So if data is not evenly distributed, so what will happen if you are running your job, so in a single executor, if that type of data will go, that will leads to out of memory issue, because the data is huge in nature. Okay, so I'll explain with example. So in simple term, you can understand data skew means data is not evenly distributed. Okay, that is the simple definition for that. Okay, so let us take an example here. Okay, first I'll take a example. Okay, let us take an example. So suppose we have the country. Okay, we have suppose country. Okay, we have country and here we have the records. Okay, so suppose there are a country like US, we have India, then we have UK, then we have Australia. Suppose. Okay, so these are the country we have. So US have 1 lakhs of record. Okay, this country have 5,000 record. India 5,000. Okay, these have 4,000 and these have 3,000. Okay, so if we have taken a data where our country versus record, so country US have this much of data, in India have this much, UK have this much, and Australia have this much. Okay, so country US has huge data. As we can see, country US has huge data like 1,000 record. Okay, and other countries are tiny. So this is called skewness problem. Okay, you can take some other example also. So some types of data, like if you are taking the record and running some data model, and in that data model, if you can see the record of female are more compared to men's. Okay, so if you will see such types of data, that is not evenly distributed. Okay, and that is the data skewness problem. Okay, now let us understand. So this we understand. This is called data skewness. Okay. So wait, why data skew is a big problem in Spark? Okay. So why this is a problem? Okay, we have data skewness. So what is the problem in Spark? Okay. So we understand the important rule in PySpark. So if one partitions one task and one executor. Okay. Suppose this is our driver. Okay. Driver node. Then we have the resource manager. Okay, we have the resource manager, and these are all our executor node. Okay, worker node, that is called worker node, and each worker node have the executor. Okay, executor, each has the executor memory where our actual job get executed. Okay, this is called resource manager. If we understand the Spark architecture, this is the Spark architecture, right? So this is executor. that is called worker node. These are all worker node. These are all worker node. Okay, and our actual job got processed here only. Okay, so and this is the driver where collect if we perform collect operation, it comes to driver. Our so whenever we are submitting our job, we are submitting our job here, driver node. And based on the resource manager, what it will do, it will allocate the resources and it goes to the worker node for processing. Okay, so uh, we understand. So, what is the important Spark rule? Spark rule important is one partitions, one task, and one executor. Okay, so if we have multiple partitions and one partitions have the data as Qness data, so if this will go to this particular executor, okay, and this particular so every executor have some constant amount of memory. Okay, so some constant amount of memory. Let's say 10 GB. Okay, okay, it's not practical, but yeah, consider 1 GB. Okay, 1 GB is the executor memory. And if we are processing data and the data size is suppose 5 GB. Okay, so if 1 GB is the capacity and 5 GB goes to this particular executor, what it will happen? So this executor got success. This executor will be successfully process the data. But if this data will go, this particular partitions will go to this executor, what will happen? Because of out of memory issue, this executor every time it will run continuously because it will fail, it will retry, it will fail, it will retry until or unless you have handled some failure mechanism. So this job will run continuously in the loop. Okay, and some it will give out of memory issue. So that is the problem with the data skewness because one part we understand one partition, one task, and one executor core. That is the our rule of data. Okay, so that is the rule of PySpark. Okay, that is the Spark rule. So if huge data, which is the SKU data, and if it goes to one partitions, and because of executor have the limited size, it will run forever. It will give out of memory. Okay, so now we need to understand what happens with skewness. So Spark group data by key, like group by or join. Okay. So all row for the same key go to same partitions. I have already explained all row from the same key, it will go to same partitions. Okay. So large key, it means like one huge partitions. So that partition means one task. And that task goes to executor. So that run very long because it will again fail, it will rerun, it will fail, it will rerun. So the what will that task that run very long, uses lot of memory and may out of memory issue also. So these are the three problem will occur if we'll run this types of data. So one task run forever, what will be the result? One task run forever, other task finish quickly, and job took stuck. Okay, that job looks stuck, so it will got stuck forever. Okay, so that is the result we have if we have the data skewness. Okay, now let us understand how skew appears in real jobs. Okay, so if you are common operations that expose the skewness. Okay, so if we, a common operation that skew expose skewness, that is the if you are performing some join operations, if you are performing group by operations, if you are performing distinct operations, if you are performing windows. So if these are the operations, these are the common operations that expose the skewness. Okay, so a real production example we can understand. Okay, so a real production example, like suppose we have the user ID. So we have the user ID. Suppose like we have the user ID. So this user ID where one user is extremely active, that is extremely active. Okay, so and the country is US. So we have taken a user ID, that user is extremely active, country is US, then status is active. Okay, and date is today. We are taking some example, date is today. Then we are taking null key. Okay, null keys. Okay, so these are the real production example. If you are taking like user is extremely active, and if you are taking the data from country US, because US have already the SKUs data. So if we will take, if this data will go to our real production, that SKUness problem will definitely occur. Okay, if we'll perform this operation on our this data, so these types of problem definitely occur. Okay, now we need to understand the symptoms of SKUness. So what is the symptoms of skinniness, or how to detect it? Like how to detect it? How to detect the skewness? Okay, how to detect it? So in Spark UI, if one task takes much longer than others, that is the issue with data skewness. One executor uses much more memory, that is the issue of data skewness. Job stuck at last stage, that is also the issue of data skewness. Okay. So I have given this as a like theoretical things which we can understand for our interview, and we can make a point also for interview. Okay, and we can understand in logs also we can see if there is a executor out of memory, that is the issue with that is issue with the data skewness. Task retry multiple time. Obviously, if our executor have less capacity, and this is suppose this is our executor and worker node, and this executor have some limited memory, and our task is running on that, on this one, and this task have partitions, huge partitions. Okay, this task have huge partitions. So if it will go to, it will go and process to this particular executor, what will happen, it will every time it will retry because of memory issue. Okay. Okay, so in log we can see the task retry multiple time. Okay, so what is the tips for that? Okay, so skew is visible as long as running task in a Spark UI. So if running task is there in a Spark UI, we can see there is the skewness problem. Okay, so we now, so as of now, we understand what is data skewness. So what types of data have data skewness problem, from where we can detect, okay, and how skew appears in real world, okay. Then we understand why data skew is a big problem in Spark. Okay. Now we can see the problem solution also. Solution of data skewness. Okay. That is important to understand what is the solution. So first solution we will see, this is the first solution. This is the first solution. We will see the salting key. What is salting key? So salting key is like break one big key into a multiple smaller key. Okay. So let us understand with example. So earlier we have a user ID user ID 123, and that has the 10 million record. Okay, so that is big, very big partitions. Okay, that is very big partitions with which have the tail menu record, and that is the user ID. Okay, so if you'll do some sorted, so what do you mean by sorted? Sorted means add random number to the key. So if we are adding random number, so if you are adding like, if user ID is 123, so how we are adding it? We are adding like 123 underscore 1 2 2 underscore 2 underscore 3. So we are adding the random number. So add random number to the key. So what will happen? Data spread across partitions. So this data will spread across the different partitions. Okay, so there will be then multiple partitions. After sorting, this data will be the multiple partitions. So if multiple partitions means this the partition size will be less compared to this one. So this will solve our problem. Okay, so data spread across multiple partitions. This is one partitions, this is second partition, this is third partitions. So multiple tasks process the data. So these different partitions are processed by executor 1, this is processed by executor 2, and this is processed by executor 3. Okay, so how this will solve the problem? Like if we are adding the random number to the key, data is spread across partitions, multiple tasks process the data. So in that case, no single heavy task. Okay, so no single heavy task. Okay, so how to do that? So I'll write some code if it is required. I'll write some code also. Okay. So I have already explained how it works, like random number, data spread across partitions, multiple task process data, no single heavy task. So sorting distribute skewness across multiple partitions. So that is the solutions we have. Okay. So in PySpark, how we are doing that? Like we are writing like from. So how we are writing here? So we are writing like from PySpark from PySpark.sql SQL function import import concat concat column, then rand, then floor. Suppose we are done. Okay. Then we are defining some function df equals to df dot with column with column. Then we are using like salted underscore keys comma concat. Then we are passing column. Then we are passing user underscore id. I have taken the example user id and then dash floor, then rand rand, we are taking the random number multiply by 10. So what we are doing basically here, we are just taking a random number. Okay, we are using the rand function, so random number multiply by 10. So we are using the sorted key as a, we are concatenating with the column user id, and user id we are multiplying with random number multiplication by 10. So we are generating the random key. Okay, so if you are generating the random key, so what it will do, it will distribute skew data across multiple partitions. So this will solve our problem. Okay, so this way it will solve our problem. Okay, so we need to always remember sorting distribute skew key across multiple partitions. So if it will across multiple partitions, it will got distributed, then what will happen, then our problem will get solved. Okay, now let us understand the second problem is broadcast join. Okay, so when to use broadcast join? So if one table is small and other table is skewed. Okay, so one table is small, that is small enough, and one table is small enough, and other is the table two is skewed. That is the skewed. Okay, okay. So if that is the problem, when so how it will help? So what we are doing, we suppose we understand like this is driver node, this is driver node, this is our resource manager. Okay, and this is the our worker node. Okay, worker node, this is our worker node, this is our worker node. Okay, so how it will help? So in this case, small table sent to all executors. So what, how broadcast will work? So in case of broadcasting, because this is a small table, so this will be always sent to all executors, so that it will get a storage to the execute storage memory as a broadcast variable. Okay, and if it is required while execution, it will use that data. So if we will do that, we will do that way. It means that there is no shuffle. So in that case, so a small table if sent to all executor, what will happen? No shuffle on big table. Okay, this is the one solutions we got. Then SQL problem will disappear. Okay, so broadcast join also if we are using, we are just reducing our we can say data skewness problem. Okay, so how we are using in PySpark, I'll explain with the code also. So suppose here I am writing from from PySpark from pyspark.sql, this get SQL import pyspark.sql function, pyspark.sql function import broadcast. Okay, broadcast. Okay, then we are doing defining like df underscore big dot join. Okay, we are performing join on small data set. So what we will do, we are broadcasting. So broadcast df underscore small, okay, and then we are passing the ID. So based on ID, we are doing that. Okay. So if we will do that way, this will solve our problem. Okay. How broadcast? So broadcast does not fix skew everywhere, only in joins. So in case of joins, so broadcast does not fix skewness problem everywhere. Okay. So only broadcast will work. Okay. Broadcast will work only in joins. Okay. So only in case of joins we can use broadcast. Okay. Broadcast will work only in case of join. Now, coming to the third problem, okay, that is third things, custom partitioning. So this is basically the default like behavior, okay. So Spark uses the hash partitioning. Hash means we are giving like hash and some key, and then we are doing the num partitions, okay. So this way also. So what is the problem? So problem is like if you have the skewed key and same hash function if you are using, so it will go to the same partition. That is the problem we have. So what is the solutions we have? We are just defining the own partitions logic. Like how we are defining the one partitions logic. So on partitions logic we are using like df dot. Suppose here we are doing df dot repartitions. Okay. df dot repartitions if you are doing like 200 and then we are passing the key. Okay. So if we are doing this way, so partitions by composite key. So it will the or add a secondary column or we can use. So this is basically the partition by composite key. This is basically the defining our own logic or you can use partitions by composite key. Okay. Partition by composite key also or you can add secondary column also. Okay. Secondary column also you can use. Okay. So these are the anything three problem we can do. Either you can use custom hash function partitions logic. Okay. Custom partition logic or partitions by composite key or you can use secondary column. Okay. So this is also the way to reduce the you can say data skewness. Okay. So composite partitions improve bad balancing. So if we have the bad balancing, it will what it will do? It will improve. So it will improve it will improve bad balancing. Okay, it will improve the bad balancing. Okay, so this way it will solve. And the list and the last is AQE. Okay, so we have already seen that is very important. AQ is the adaptive query execution. Okay, so this is one of the most important I can say solution for data skewness. Okay. So what is AQE basically? So Spark dynamically change execution plan at runtime. Okay. So what is so that is adaptive query execution. What is that? So Spark dynamically change execution plan at runtime. Okay. So that basically so so how it work basically? So AQI what does? So what AQI does? So that detects the skewed partitions and that split large partitions and then change the join strategy. Okay, and then it reduce the support. So these are the step it basically do to reduce the adaptive query execution. Okay, so that we need to enable. So if we are facing some problem, so AQE automatically handle SQL join at runtime. Okay, so how to like so how we are enabling that. Okay, so that is the main problem we have. So how we are doing that? So we are using like a spark.com. So in configuration you have to do that. Okay, you have to do like in configuration. So how to enable the AQI if your job you are facing problem, so how to enable that? Okay, so I'm telling how to enable that a spark.conf a spark.conf then dot set we are passing set. What we are passing? We are passing right spark dot sql dot adaptive adapt adaptive dot enabled. Okay, enabled. So adaptive enabled if we are passing spark dot sql dot adaptive enabled if we are passing like true. Okay, if you are passing like true, so it will enable the AQI in your solution. So always do that if you are facing the problem in your configuration setting. So you have conf file, like conf file. In conf file, configuration file, always change this setting. Okay, enable AQE. So if we'll do true, it will do AQ automatically handle the joins at runtime. Okay, so as of now, we have seen the solution like AQ is the one solution, other is the custom partitioning, other is the broadcast join, and then we have seen that how salting will work. Okay, then we understand how to detect like how to detect if there is a data skewness in your job. What is data skewness? What is the problem with the data? Okay, if there is, what is the problem with the data skewness if that is existing in your job? So we have seen all these things and we have seen the solutions also. Okay, and so lastly, I have summarized which solution to use in which scenario. So I have explained the scenario and I have explained the base solutions also. So if there is a SQ in join and a small table, you always use broadcast join. Okay, so always remember if skewness in join and a small table, always use broadcast join. One key extremely large, always use salt. Okay, so salting we have to use when there is a extremely large. So add the random number. If many medium skew data skew key is there, always use AQE. Okay, if partitions imbalance are there, always use custom partitioning. Okay, so these are the solution and these are the problem. If these types of problem happen, this is the solution. If these types of problem happen, this is the solution. Okay, if a partition imbalance is there, the custom partitioning is the solution. Okay. So that is the and that I have explained in the previous video also, like why SQ causes out of memory. Obviously we know, like because if one task process huge partitions, so that needs larger memory, and if larger memory is not available, obviously executor will crash. Okay, so SQ means uneven memory uses. Okay, that is uneven memory data also, and that is uneven memory uses also. So because of uneven memory uses, our out of memory problem will occur. Okay, out of memory problem will occur at the executor side because executor don't have the sufficient memory to handle that big partitions, and that big partitions is because of data skewness. So main problem is the data skewed. Okay. Okay. Okay, thank you, thanks for watching.